And then this one. And you can use the pointer, the mouse, the pointer if you want it. All right, thanks for your patience through all of this. I'd like to introduce our next speaker from WSU, from the DeVetter Lab, Weixan Gan. She's going to give a present on promising strategies that can improve blueberry pollination.
Thank you. Hello, everyone. I'm Weixan Gan, a master's student from WSU Northwestern Washington Research and Extension Center in Mount Vernon. And I came to the United States in August last year to study about blueberry pollination with Dr. Lisa DeVetter. So I'm a new beginner of blueberry, and it's my honor to present here in a small fruit conference. And today I'm going to talk about promising strategies that can improve blueberry pollination. Before this talk, I want to share a story with you from which you will know why we study blueberry pollination and why growers should care about blueberry pollination. And here is a photo we took in April 20th this year. Dr. Lisa DeVetter and I used mesh bags to block the pollination from pollinators like honeybees. And 3 months later, we checked the berries, and there is a huge difference. The left clusters are not pollinated, while the right one is pollinated. It has more berry and it has better berries. So adequate pollination is important. It related to how many berries you can get and how much money you can make. Now let's get into my research. Promising strategies that can improve blueberry pollination in Western Washington. And I will talk about from these 5 aspects: background, objectives, experimental method, and results, conclusions. And Washington State leads the nation of blueberry production, and 2% more than last year. Good job, everyone. And this industry is mainly located in western part and eastern part of Washington State. Growers usually rent honeybee hives to pollination, and because honeybees are commercially available and there is a lack of other potential pollinators. Even though we have additional honeybees, but pollination in Western Washington is still poor. And there are many factors to cause a poor pollination in Western Washington. And here I'm going to list some of the main factors. And here is a typical blueberry flower. And you can see this part, corolla throat, is pretty narrow. And it has a perfect bell-shaped flower with a long corolla tube. And this shape affects pollination a lot because honeybees' short tongue length may not extend down through this long corolla tube to touch the pollen at the bottom. And honeybees cannot sonicate to cause an effective pollen release. And the weather condition in Western Washington make the pollination issue even worse because we usually have a windy, cold, and rainy spring in Western Washington. And this kind of weather is good for sleeping at home. Same for honeybees. And the bloom period is very short, only 5 to 12 days, and even less. And the pollen longevity is also short. So all these factors make pollination by honeybees is so hard in Western Washington. From a previous study, increasing hive density can be a very promising way to improve pollination of high bush blueberry. And increased hive density promotes pollination, berry size, and estimated yield of duke in Western Washington, and they found the economic returns can compensate the rent of additional honeybee hives. But where is the point of diminishing returns? Higher hive density should also be tested again in duke. And these years, there are many other commercially important cultivars in the market, like Draper and Liberty. And please look at this photo. Pay attention to Duke. It has a widest corolla throat, and it has a wide corolla tube. So pollination of Duke should be easier than other cultivars. So does higher hive density also play a role in other cultivars? I choose another cultivar Draper to test the hive density. Now assume we already have enough honeybees in our field. How could we trigger them to be hardworking honeybees? The answer may be pheromones and attractants. And some of the products are now widely used by growers. Pheromones are chemicals produced by insects and released into the environment, affecting behavior and the physiology of the other individuals within the same species. For example, fruit pheromone is produced in the larval salivary glands. It has been proved to trigger increased foraging, while egg laying is maintained the same level. And honeybee queens can also produce another kind of pheromone, queen mandibular pheromone. It's fed to attendant to slow down the hive growth and deter reproductive swarming, further to increase hive strength and foraging activities. And now there are many synthetic pheromones and attractants in the market. Synthetic pheromones are chemical produced to mimic the natural pheromones. And attractants are chemicals that can simply allure or attract an organism, for example, by scent, like perfume. And according to the label of this kind of products, they have an amazing effect on improving pollination, and they can last for a long time after applying, even though it's windy or raining. Anyway, according to their labels. And there is a study about bee scent as a commercial pheromone product, and they found it didn't increase honeybee visitation and yield characteristics on Draper. And there are limited information about this kind of stuff, especially on high bush blueberry in Western Washington. So I'm very curious about this kind of synthetic pheromones and attractants. So I conducted the pheromone experiment on Draper, including 4 different kinds of synthetic pheromones and attractants to see whether they have a good effect on improving pollination in blueberry. And here is my objective: to evaluate commercial strategies that have the potential to promote pollination, fruit set, yield, and the fruit quality attributes in Western Washington. And these strategies include increasing honeybee hive density and application of commercial pheromones and attractants. And all these experiments are conducted during May to November in 2018. And there are 16 conventional managed fields were used in this research. and they are across Skagit County and Whatcom County, where is a red star in this map. And the first experiment, hive density experiment in Draper. There are 6 field sites, 3 transects in each site, and they are at least 1 mile apart. And we introduced the honeybee hives into the field around 5 to 10% bloom. And each treatment replicated 2 times. That is, 2 field sites has 4 hives per acre of honeybees. That is the control group. And the two fields have 8 hives per acre of honeybees, and 2 fields have 10 hives per acre of honeybees. And there are 8 frames in each hive, and that is around 30,000 healthy bees in each hive. And the second is hive density experiment on Duke. The experimental methods are the same as the Draper one. And the last one is pheromone experiment in Draper. There is 1 field site, 4 rows, and 6 treatments in each row. And we also maintain a buffer zone around each side of plot to maintain the independence. And we unify the hive density as 4 hives per acre because this is the common stocking density in Western Washington for blueberry. And all the application was based on the product labels. And here are the products we used in pheromone experiment: Bee Scent, Pollinate Pro, Honeybee Magnet, and Shoeset Apex. Some of them are very widely used and some of them are pretty new. And Bee Scent is a liquid product, so we have a distilled water treatment for control. And other products are dry products, so there are no water group for control. And the application for these pheromones products are very interesting. Some of them are they have very good scents like perfume. Some might sound like shampoo. And this is Bee Scent, is the liquid product. We need to prepare it to a specific concentration according to the label and just spray on the bushes. And this is the Pollinate Pro. It's a very sticky blue color gel material, and we need to squeeze it on the crown. And this is Honeybee Magnet. It has a flavor of lemonade juice. I like it very much. And it's in a small package, so it's very easy to hang on the bushes. And the last one, Shoeset Apex, is a powder material, and we need a machine to spray it. And here I have a very quick, very short video. I hope I can play. Yes, this is Dr. Lisa DeVater. And for the data collection, we measure the honeybee visitation and abundance data by counting the legitimate pollination events conducted by honeybees. Please look at the photo on the left. It's a legitimate pollination event. What's that? It occurs when a honeybee forages within a flower and enters using its head to touch the pollen, rather than just bypassing the pollen and dig a hole on the petals and suck the nectar, just like the photo on the right. So we count how many bees conducting legitimate pollination events within 1 minute interval and repeat it 3 times per sample bush per day in total for 3 days during the whole blooming season. And we count the number during the daytime when the temperature is higher than 55 Fahrenheit and there's no strong wind, no rain. And we also count fruit set, calculated estimate yield per plant, and we collected sample berries from the field and measure berry diameter, weight, and firmness, and also degree breaks and estimated seed number. The degree break is the sugar content in a solution. For example, 1 degree breaks is 1 gram of sucrose in 100 gram of solution. And for estimate the seed number, we extracted seeds from 10 berries in each replicate and weight the seeds and divide it by the average seed weight to calculate how many seeds in each berry. And the machine on the upper left is what we use to test the degree breaks, and the right one is what we use to test the firmness. It has a pressure to press the berry, and it can also tell the diameter of the berry. The result will pump on the computer screen very quickly. And let's get into the most exciting part. This is the dripper fruit set at different hive densities. Green color stands for the 2 fields with 4 hives per acre, and blue color is the field with 8 hives per acre. Yellow color is the field with 10 hives per acre. The y-axis is the fruit set from 0 to 100%. And numerically, we can tell 4 hives per acre has the lowest average fruit set, which is in the green color, and 10 hives per acre in the yellow color has the highest average fruit set. Now let's look at the more detailed data. And here has the vegetation, fruit set, fruit diameter, fruit weight, firmness, degree breaks, estimated seed number, and yield data. And we can know there are significant difference in both vegetation and fruit set because the p-value are less than 0.5. And 10 hives perform very well. It has the highest vegetation rate and highest fruit set. And there is no significant statistical difference in fruit weight, degree breaks, estimated seed number. And please pay attention to the firmness. They all have very high firmness. Everyone is above 200. That's very high. And let's pay attention to the blue color number. 10 hives per acre has the highest firmness. But this is not always a good thing. Please look at the fruit diameter. It has a smallest diameter. So this may suggest a small size berry is tend to have a higher firmness. And what about the yield data? Even though there is no difference statistically, but let's check the number. 8 hives per acre and 10 hives per acre has a almost double yield to 4 hives per acre. Maybe there is no statistical difference, maybe because the yield sample is small. But let the money tell the story. Let's calculate the economic returns. Using price times weight and minus the cost for hives. Let's just ignore the other costs because different farms may have different management costs. Just pay attention to the difference in numbers. And the average blueberry price is $1.06 per pound according to USDA. This is the average price over the past 3 years. And the cost for hive is $39 per hive. And here is the result. 10 hives per acre has the highest economic returns. And let's see, is it the same in the Duke? Here is the Duke fruit set at different hive densities. Green color is the fields with 4 hives per acre, blue color is 8 hives per acre, and yellow is 10 hives per acre. And numerically, we can see 4 hives per acre in the green color has the lowest average fruit set, while yellow color, 10 hives per acre, has the highest average fruit set. And here's the vegetation, fruit set, fruit diameter, fruit weight, firmness, degree breaks, estimated seed number, and yield. Still, there are significant difference in vegetation and rate. 10 hives has the highest vegetation rate, and it has almost 100% fruit set. That's what we are looking forward. Still, there are no significant difference in fruit weight, degree breaks, estimated seed number, and yield. But after checking the number of yield data, I believe you will vote for 10 hives per acre. Yeah, in my opinion, that's a huge difference. And still, let the money tell the story. Here is the economic returns. 10 hives per acre has a highest economy return. So this strongly suggests that higher hive density will cause a better pollination and a higher economy returns. Let's look at a pheromone experiment in the dripper. And this is the dripper fruit set when using different pheromones and attractants. Every color stands for a material, and we can see they are very similar to each other. And the fruit set is ranged from like 60% to around 70%. That's pretty low. And numerically, B-scent, which is in the green color, has the lowest average fruit set. And Pollinate Pro in the red color has the highest average fruit set. Let's look at the detailed data. Here are the vegetation, fruit set, firmness, fruit diameter, fruit weight, degree breaks, and estimated seed number. We can see Pollinate Pro has the highest vegetation with 0.18 bee per bush per minute. That's very, very low. This field, I don't know the exact factor why it has a poor pollination, but it's a very good sample to test the pheromone materials. But after applying all these kind of products, the pollination is still very low. And there is no difference in fruit set, fruit diameter, fruit weight, degree breaks, and estimated seed number. And here comes the conclusion. Increasing honeybee hive density is a very good way to improve the pollination. It can increase honeybee visitation, fruit set, and it has a positive trend to increase yield and economy returns. But we still need to repeat this experiment in next year to confirm this year's results, because some of the data of the fruit quality, they are mixed, so we need to repeat it again. And for the pheromones and attractants, the honeybee visitation and fruit set are still low. And we also need to repeat it to confirm the result this year. And we may include other products that growers interested in. And at this point, I want to thank Sean Watkinson, Huang Zhang, Nadia Boston, Matthew Arrington for their technical assistance. And I want to thank my advisor, Dr. Lisa DeVetter, and my committee member, Dr. Beverly Gertman and Dr. Matthew Whiting. And I want to thank Washington Blueberry Commission and Northwest Agricultural Research Foundation for providing funding for this research. And I want to thank all the cooperative farms for their cooperation and help. And thanks everyone for listening.
This one works. Just are fun.
So, Weixan, great job.
Thank you.
I just wanted you to elaborate a little bit more though. Did all of your higher hive density sites, like the 8 and 10 hive per acre site, particularly in Duke, have higher visitation, or did you sometimes see instances where even with high hive densities, we still saw low pollination?
Yeah, in one field, it has 8 hives per acre of honeybee hives, but it has a very, very low pollination, very, very low fruit set and honeybee visitation rate. Lower than the 4 hives per acre fields. The reason may be in the soil, they have too much organic matters, so they have very strong vegetable growth, but they don't produce many fruits. So I think increasing hive density should combine with other management strategies like soil management, nutrient management to get a better pollination results.
Yeah, and I'm Weixan's advisor, so I just want to make sure that what we're presenting, this isn't a silver bullet. There's a lot to figure out when it comes to pollination, but we're repeatedly seeing a lot of potential and promise with these higher hive densities. But again, it's not going to be a cure-all. Yeah. Okay.
Hi, thanks for your talk. It was very interesting. I was just curious if you could say what the average hives per acre are currently used in the production fields.
In Western Washington, the blueberry growers usually use 2 to 4 hives per acre. Yeah, that's according to my experience.
Thank you for your presentation. Just had a quick question. Did you evaluate the difference between on the Duke field, you put 4 hives per acre, and then the other test you did 4 hives plus the pheromones and the attractants. What was the difference there?
Do you mean the honeybee visitation between the hive density experiment and pheromone experiment?
Yeah, have visits and the actual tonnage per acre.
Actually, the pheromone experiment field has a very low pollination rate, so I don't think it's a very good example to compare with other fields. Yeah. But for the Draper and Duke, at the same hive density, the Duke field has a higher fruit set and higher visitation rate, maybe because the flower shape of the Duke is easier to pollinate.
Do we have any more questions? Well, in that case, I'm actually going to hand it back over to Weixan for a second talk.